Hello viewers, welcome back. In this video lecture we are going to talk about the Reimer-Tiemann reaction. This is one of the important reaction of phenols. First, we learn the general reaction. Here the phenol reacts with chloroform in the presence of a basic medium, either sodium hydroxide or potassium hydroxide. It gives salicylaldehyde. First we should understand it. So this reaction is preceded by aromatic electrophilic substitution reaction. Okay, this we already learned in the general reaction mechanism of aromatic electrophilic substitution reaction. First step is it should form a electrophile. That electrophile generation is the first step. Later the pi electron of the benzene will attack the electrophile and we will get the electrophilic substitution product. That means in this reaction how the electrophile is going to generated. First we will look into that. The electrophile is generated in the form of carbene. Okay, that we are going to see now. Here this basic medium, that OH, the base, is going to abstract a proton from the chloroform, and this one, this hydrogen donates its electron and the chlorine is going along with electron pair and it forms a dichlorocarbene. Okay, so this reaction is a one type of elimination reaction, and specifically it is an alpha elimination. For your kind information, we already discussed the elimination reactions and its type that I given in the description link. Please go through it. Okay, so the dichlorocarbon is formed by through help of alpha elimination mechanism. Okay, now this has been formed, so this is called as a dichlorocarbene. Now this is going to act as an electrophile. Now we will discuss the nature of a carbene. How this is going to act as an electrophile. We could have learned that the carbene is a neutral species. You look into that. So there are there's one lone pair, that is 2 electrons, and 2 are in the bonding, total 4 electrons. So that means here the carbon is having the complete valence electron 4. Okay, we are having 4 electrons, then definitely it should be a neutral species. Okay, however this can act as an electrophile or nucleophile according to the nature of the carbene. Now this carbene can either behave as a singlet carbene or a triplet carbene. For your understanding, for your fundamental understanding, I am going to tell you what is singlet carbene. Singlet carbene means if this lone pair electron in the carbene, if it is in the pair. Okay, here you see in the dichlorocarbene both are in the pair. So that's why this is called as a singlet carbene. The triplet carbene means it should be in the unshared. Okay, sorry, it should be in the unpaired. It will be in the unpaired like this. This unpaired carbene can behave as a radical. Here it is behaving as a diradical, so it can behave as a diradical. Clear? So here the formation of dichlorocarbon is acting as an electrophile, and the electrophile or nucleophile can be is according to the type of the substituents connected to the carbon. If the carbon is connected with the more electron withdrawing group, here the chlorine are there, So that means this carbene can act as an electrophile. That's why here the dichlorocarbon is acting as an electrophile. I hope you understand it. Okay. Now the electrophile is generated and it is ready for the attack. Now what will happen? Now this benzene, now this phenol is going to react, or in the presence of sodium hydroxide it forms a phenoxide ion, because we already learned phenol is highly acidic in nature, so in the basic medium, so it can donate the proton. Okay, that we learned it. Now what is going to happen? Now it's going to react with dichlorocarbene like this. Now this is going to act as an electrophile, so this lone pair comes here and this is going to attack, and finally you will get this one. So please see that I am rotating the electrons in proper sequence. Okay, now this will like this, like this. As we know, as soon the aryl system loses its aromaticity, so what it will do? It will try to regain its aromaticity by losing the proton. You see this, now it became this negative charge. Okay, now the carbon became negative charge. You see here 5 electrons. Now this will abstract this proton, and this hydrogen donates its electron to the benzene ring to stabilize the aromaticity. So finally we will get like this. So phenoxide ion, and we get like this, like this. Okay, here it is a chlorine, no? Here it is a chlorine, sorry, here it is a chlorine. Okay, now this is called as benzol dichloride. So this is called as benzol dichloride. If it is phenyl CH2Cl means that is benzyl. If it is CHCl2 means that is benzol. Okay, so you should know the name also. So if you do that hydrolysis, one of the chlorine will be replaced by the OH. So you will get it like this, the phenoxide ion, now this will become OH, I am putting Cl and this hydrogen. Now what it will do is this, with the phenoxide ion, it will abstract the proton, and this hydrogen donates its electron, and the chlorine will go along with electron pair, and finally we will get like this. This will become OH, and this one becomes C double bond OH. So this is the salicylaldehyde. Here you should remember that we always discussed any ortho-para director. Here the OH group is an ortho-para director. We should always get both ortho and para. Please remember that in a Reimer-Tiemann reaction, this electrophile, that is the formyl group, is always substituted at ortho position. Okay, this is the one notable point we should always remember
it will gives the ortho product as a major product. So this is called an Reimer-Tiemann reaction. So I hope you understand this reaction. Kindly subscribe and share it. Thank you very much.